You're walking into a room full of strangers. Your heart rate climbs, your palms sweat. Nothing in that room can bite you, claw you, or chase you down. So why does your body react like it's in danger? The honest answer is stranger than you think. For most of human history, the thing that could actually kill you wasn't a lion in the grass. It was the group deciding you didn't belong to it anymore. A predator might kill one person on one bad day if the timing lined up wrong. But exclusion? Exclusion killed slowly, and it killed almost everyone it touched. No food, no fire, no one to watch your back while you slept. Your fear of judgment isn't some modern glitch. It's an inheritance, and it's older than fear of teeth and claws ever was. Let's go back. 200,000 years ago, a human alone on the savannah was not a survivor story. It was a death sentence, just a slow one. Early humans weren't the fastest animals out there. They weren't the strongest either. A lion could outrun any of them. A hyena pack could outlast them. What humans had was each other. Cooperation was the actual weapon. Numbers were the actual armor. The anthropologist Sarah Blaffer-Hrdy spent decades studying this exact question. How did a slow, clawless, fangless primate become the dominant species on Earth? Her research pointed to something called cooperative breeding. Human infants are helpless for years, not weeks. Raising them required more than one set of hands. It required aunts, grandmothers, unrelated group members, a whole web of people willing to invest in a child that wasn't theirs. That web only worked if everyone stayed inside it. So what happened if you got kicked out? You didn't just lose friendship. You lost your food-sharing network.
You lost the people that'd pull you from a riverbank if you slipped.
You lost your early warning system for predators because a lone human has no one to keep watch while they sleep. Exclusion wasn't social discomfort. It was a resource cutoff, a security failure, and a death sentence, all wrapped into one event. This is where your brain comes in, because your brain doesn't know the calendar changed. The psychologist Kipling Williams ran a now famous experiment called cyberball. Picture three people playing a simple game of catch, tossing a virtual ball back and forth on a screen. One participant is real. The other two are just part of the software. At some point, the two virtual players stop throwing the ball to the real person. That's it. That's the whole manipulation. No insults, no threats. Just being left out of a ball toss with strangers who don't even exist. And people's brains lit up like they'd been physically struck. Williams found that the same neural regions associated with physical pain, particularly the anterior cingulate cortex, activated during social exclusion. Not something similar to pain, the same circuitry. Your brain doesn't file left out of a game and hit with a rock into separate folders. To your oldest wiring, both mean the same thing. The group might be pulling away from you, and to a Pleistocene brain, that was the single most dangerous sentence in the world. What made the cyberball findings even stranger was who they applied to. Williams ran versions of the study where he told participants beforehand that the other players were computer programs, not real people. It didn't matter. People still felt the sting of being excluded, even when they knew, consciously, that there was no one on the other end to reject them. That's how deep this circuitry runs. It doesn't wait for your rational brain to confirm the threat is real. It fires first and lets you sort out the details later, the same way it would have fired at a shape moving in the grass, long before you consciously identified it as a lion. This is the part that separates humans from most other threat responses. A fear of heights makes sense at a glance. A fear of snakes makes sense at a glance. But a racing heart over a video game with fake players? That only makes sense once you understand what the feeling was actually built for. It was never really about the ball. It was about the possibility of the group closing ranks without you. Consider what exclusion actually looked like on the ground, physically, day to day. Anthropologists studying modern hunter-gatherer societies, groups like the Hadza in Tanzania or the Juhoansi in southern Africa, have long noted how central shared food and shared shelter are to daily survival. A single hunter rarely brings down large game alone. A single forager rarely finds enough calories day after day to sustain themselves through lean seasons. The group wasn't a nice-to-have. It was the actual infrastructure of staying alive. Remove yourself from it, or get removed from it. And you weren't just sad, you were structurally undefended. And it wasn't only about food. Sleep is one of the most vulnerable states a human being can enter. Eyes closed, muscles slack, no awareness of the surrounding world for hours at a stretch. A group sleeping together could take turns on watch, could hear a rustle in the brush and wake the others. A person sleeping alone had no such backup. Every predator on the plain understood instinctively that a lone target was an easy target. So did early humans. Staying close to the group wasn't a preference. It was the only version of nighttime that didn't end in disaster more often than not. Here's the twist, though. You'd expect natural selection to favor the boldest individuals, the risk-takers, the ones who didn't care what anyone thought. But that's not what happened. Evolution didn't reward indifference to the group. It punished it hard. The individuals who felt nothing when they were excluded didn't correct their behavior. They kept doing whatever got them excluded in the first place, and eventually they were left behind for good, quite literally. Meanwhile, the individuals who felt a sharp, almost unbearable discomfort at the first sign of social distance, they changed course immediately. They apologized. They contributed more. They stayed inside the group. So the anxious ones survived. The thick-skinned ones often didn't. Isn't that the opposite of what you'd expect? The anthropologist Robin Dunbar took this further with his research into what's now called the social brain hypothesis. Dunbar found a striking pattern across primate species. The bigger a species' social group tends to be, the bigger its neocortex is, relative to body size. Humans, with our enormous social networks, have some of the largest neocortices of any primate. Our brains didn't get big to solve math problems or build tools. They got big to track relationships. Who owes who a favor? Who's mad at who? Who might turn on you next? Your intelligence, in other words, might be a byproduct of your anxiety about being left out. Now here's the part that should genuinely unsettle you. Your amygdala, the part of your brain responsible for detecting threats, cannot tell the difference between a predator crouched in tall grass and a friend who hasn't texted back in 3 days. Both trigger the same alarm. Both flood your body with the same stress hormones. You are, quite literally, running threat detection software built for lions on a modern problem involving read receipts. The researcher John Cacioppo spent much of his career studying loneliness, and what he found should sound familiar by now. Chronic social isolation doesn't just feel bad. It raises cortisol levels. It increases inflammation. It's associated with higher risks of heart disease and early death, comparable in some studies to smoking. Your body is still keeping the old ledger. It still treats disconnection as a physical threat to your survival, because for nearly all of human history, it was exactly that. So think about your own life for a second. That group chat you keep checking. The meeting where you replayed one comment for hours afterward, wondering if it landed wrong. The itch to know if your post got likes or got ignored. None of that is weakness. None of that is oversensitivity. That's 200,000 years of evolutionary programming, doing exactly the job it was built to do, in an environment it was never designed for. Here's the strange part, though. The threat used to be real. Exclusion used to mean starvation, exposure, and early death out on the plain. Today, the threat is almost always symbolic. Someone left you unread, someone didn't laugh at your joke. Nobody is going to die from either one. But your body doesn't know that. It's still bracing for the tribe to walk away and leave you out there alone. And the modern world has done something strange to this old wiring. It hasn't removed the threat. It's multiplied it. For most of human history, your entire social world was maybe 50 people, a band, a camp, a handful of families who knew your name and your face. Dunbar's research suggests the human brain is built to comfortably track around 150 meaningful relationships, sometimes called Dunbar's number. That's it. That's the ceiling your ancient hardware was designed for. Now think about how many people can technically reject you in a single afternoon. A post that gets no likes isn't just quiet. To the oldest part of your brain, it can register as 50 silent verdicts, 100, 1,000, all at once. Your threat detection system, built for a village, is now running calculations for an audience the size of a small country. No wonder it feels like too much sometimes. It was never built for this scale. Maybe that's worth sitting with. Not to make the anxiety go away. It probably won't, not entirely, and it's not supposed to. It's doing exactly what it evolved to do. But maybe understanding where it came from changes how loud it gets to feel. There's a kind of relief in that, if you let there be. The version of you that checks the group chat twice, that replays an awkward pause in a meeting, that feels a small jolt of dread before opening a message from a friend, isn't broken. That version of you is running an ancient, well-tested survival system, one that kept your ancestors fed, warm, and alive long enough to have you. It just hasn't been updated for a world of screens and strangers and audiences it was never designed to calculate. You're not weak for feeling it. Your old software doing exactly what it was built to do in a world that changed faster than biology ever could. So you're walking into a room full of strangers. Your heart rate climbs, your palms sweat. Nothing in that room can bite you, claw you, or chase you down. But your ancestors would understand exactly why you're afraid.